Everybody, how are you? Today we'll complete 12 questions from MATHS book about limits. Look at this example. If limited when x approximated to 0, then 1 plus ax over 7x equal a over or 2 over b, then a times b equal space. We know the rule here. We can write 1 over 7 outside between two terms here, len and limited first. Limited when x approximated to 0 about len 1 plus ax over x detail as the result equal to over b. We know in the theorem the result here coefficient of x will be a, then 1 over 7 times a equal to over b. Doing multiplication about the product of extremes equal to the product of means, then a times b equal 7 times 2, then ab equal 40. The result will be 40. Look at this example. Limited x approximated to 0 to power 2x minus 2 power 3x over x. We can add 1 and subtract 1 from this expression to doing what? To do the theorem. Limited here when x equal to 0 to power 2x subtract by 1 over x. I add here negative 1 and negative 2 power 3x plus 1. I will write limited when x approximating to 0 to power 2x minus 1 over x, subtract here limited when x approximated to 0 about this function to power 3x minus 1 over x. The result here equal what? We have limited here x to 0 and we can convert it, or multiplication by 2 here and 2 here, and here multiplication by 3 and multiplication by 3 here. So we have the theorem here. It will be what here? We have the same base. So the result will be len about what? About 2. So the result will be 2 outside here, multiplication by len what? The constant here, len 2. Subtract. Write 3 here and len. Here is the result. Limited about this function, limited len about constant. We need 2. Understood? We can write 2 in the power here. It will be len 4. Subtract by len 2 power 3 equal 8. I will drop here 2 in the power and 3 in the power. We have the difference between two lines, so we can convert it to divided by the two constant here, 4 over 8. So the result will be len half. Okay, the result will be len half. Len half. Okay. Limited x approximated to 0, 10 power x subtract 2 power x subtract 5 power x plus 1 over x sine x. We can write 10 here 2 times 5. Okay, limited when x approximated to 0, 2 power 5 multiplication by 5 2 power x, because we have the power x here, 2 power x multiplication 5 power x, subtract 2 power x subtract 5 power x plus 1 over x sine x. And we can write here coefficient between two terms here, limited when x approximating to 0. Write to x coefficient between two terms here. The result will be 5 power x subtract by 1. Okay, it will be over what? Over x sine x. And we have a second function here, negative 5 over x. I will write here, write x sine x here. Okay, it will be what? We can write x here and sine x. Okay, I will complete the result, the total, and the next step we can write x here and sine x here. Okay, thinking with me here, I will write negative outside between two terms here, negative 5 power x negative by 1. It's a negative coefficient. Okay, because it was what? Negative 5 power x. We can use the what? Using the rule here about 2 power x, or we can write 5 power x minus 1 highest common factor between two terms here. Okay, right, limited when x approximated to 0, 5 power x minus 1 highest common factor between two terms here. The result here will be 2 power x subtract by 1. Okay, this expression divided by this expression equal 1, and here equal x sine x. Okay, and we can write here limited when x approximated to 0 about this function 5 power x minus 1 over x multiplication by limited when x approximated to 0 about 2 power x minus 1 over sine x. I write x here and sine x here, and then we can use the rule by divided by x here and divided by x. This is the rule tell us theorem. The result here will be 1 and the result here will be ln 5. Ln constant here 5 multiplication by the result here will be ln 2 over here the result will be what? Will be 1. So the result will be ln 5 multiplication by ln 2. This is the result about this example, ln 5 times ln 2. We must study hard this question. Okay, it's very important this example. Write here 10 power x equal 2 power x 5 power x, and write 2 power x height common factor between two terms here, and again write 5 power x minus 1 height common factor between two terms. I will get this expression divided by x and this expression divided by sine x here. I will divide it by x numerator and numerator. I get here the result will be ln constant here 2 and ln constant here 5 multiplication between them, and the ln when x approximating limited when x approximates to 0 about sine x over x it will be 1. Ln 2 times ln 5 equal ln 5 times ln 2. If limited when x approximates to 0, 2 power x plus 3 power x plus 4 power x over x minus here minus 3 equal ln a plus ln b. Okay, ln a plus ln b, it's meaning what? Ln a times b. Ln a times b. You can use the rule here about this limited here. We can write limited when x approximated to 0, 2 power x minus 1. Write negative 3 here, negative 1 and negative 1 and negative 1. To write the rule, because the result here about theorem will be line 2. And then we can write here plus limited when x approximated to 0, 3 power x minus 1 over x plus limited when x approximated to 0 about 4 power x minus 1 over x. Here tell us the result will be ln eb. You know the result about first term here will be ln constant here 2 plus ln constant here 3 plus ln constant here 4. The result will be ln ab. You can write here ln multiplication between 2 and 3 and 4 equal ln ab. We must comparing between AB and 2 times 3 6, 6 times 4 equal 24 equal AB. So AB, you want to find what? A times B. He asked it about AB, it will be equal 24. Then the result will be equal 24. Look at this example. If x equal e power 10x, 10x the limited when x approximating to pi over 4 about f of x subtract f of pi over 4 over x subtract pi over 4 equal space. It's meaning what? It's meaning the derivative about this function f dash of x when x approximated to pi over 4. Then we can find the derivative about the function here. It will be e power 10x multiplication by derivative about 10 of x here. Derivative about 10 equals sec power 2. Sec power 2x. When x approximated to pi over 4, put x here equal pi over 4. It will be sec power 2 of pi over 4 multiplication e power 10 pi over 4. Sec power 2 about pi over 4. We know sec is inverse about what? Inverse about cosine. Cosine pi over 4. It's meaning 45. Cosine 45 equal 1 over root 2. Power 2 equal half. And inverse about half it will be 2. And here e power 10 pi over 4 it will be 1. E power 1 equal e times 2. The result will be 2e. Limited when h approximates to 0, cotan x plus h subtract cotan x over h it's meaning derivative about the function. If we put here this function f of x, and we want to find what the derivative of the function, f of x equal what? Equal cotan x. And you want to find f dash of x derivative about cotan equal negative cosec square of x. Okay, so the result will be negative cosec power 2 of x. It's meaning the derivative about this function. It's like the theorem, you get this theorem in second 3. You remember, f of x plus 1 subtract f of x over h is the function. So the result about this example will be f negative cosec power 2 of x. It's the result about this example. Okay, negative, right? Negative. Okay. Limited on h approximate to 0. Sec pi over 4 plus h subtract sec pi over 4 over h. He put here in this example x equal pi over 4. Okay, so the function here, it will be sec x. You remember last example I solved this example by find the derivative about this function, but this function here, it's meaning what? Sec x. He put x equal pi over 4, so you can write here f of x equal sec x, and x equal pi over 4. To find the derivative about the function, the derivative about sec, it will be sec x tan x. When x equal pi over 4, then f dash of pi over 4, it will be sec pi over 4. Here it's meaning root 2. The verse about cosine 45 equal 1 over 2. To inverse it, it will be 1 over 2. To inverse it, right, root 2. Multiplication by tan 45 equal 1. So the result will be root 2. So the result will be here root 2. It's a very important example. Okay, in this example, if you get this example in the exam, it's meaning the derivative about function. Where function here, but you must cancel pi over 4 and write x, because he put x equal pi over 4. Then the original function here equal what? Sec x, and it's meaning what? F dash of x. You can find the derivative about this function and put x equal pi over 4. It's a very important example. Okay, my students. Find the limited when h equals 1 to 0, f dash of x plus h subtract f dash of x subtract by h. It's meaning what? It's meaning the second derivative about this function. Okay, this is a rule you must know. Limited when unknown here to 0, f dash about the function, it means the second derivative about this function. Okay, the second derivative here, it will be f double dash, second derivative about this function. Okay, f double dash of x. If he cancels the derivative here and here, it will be the first derivative. So you must know this rule. Limited when x approximating or h unknown, any unknown. Okay, h approximated to 0, f of x plus h subtract f of x over h, it meaning f dash of x. But in this example, he find what's the second derivative. It means the second derivative about this function, it will be second derivative about f double dash of x. It's the result. Okay, you must know these rules to find the simplest result in your exam. If f dash of x equal cosine power 3x and f of 0 equals 0, find the limited about f of x over x when x approximated to 0. You can write here, look at here, x approximated to 0 about f of x. You know f of 0 equals 0, so we can write here subtract f of 0, and here x, it's meaning x minus 0. So it will be what? It will be f dash of this function when x equal to 0, and he give us in the example f dash of x equal cosine power 3x. It will be cosine power 3x when x equal 0. Put x equal 0 here, it will be cosine power 3 of angle 0. The result will be 1. It's a very important example. Okay, the result will be 1. If limited when x approximated to 2, f of x equals 0, we want to find limited when x approximated to 1 plus f of x 1 over f of x. You remember this example, we know limited when x approximating to 0, 1 plus x all power 1 over x, it will be e. You can write this like this example by what? By right here f of x approximating to what? F of 2. Okay, f of x approximating to what? F of 2, because x approximating to 2, then f of x approximating to what? F of 2. And we know f of x equals 0, it's meaning f of 2, put 2 here, f of 2, it will be equal 0. Then this limited will be f of x approximating to what? To 0, because f of 2, it will be equal 0. Then x approximating to, it's meaning f of x approximating to 0. So we can get the rule like here. So the result will be what? E. Understood? Again, f of x equals 0. In the example here, f x equals 0. About x approximating to 2. If you put x equal to here, the function f of 2, it will be 0. And limited about x approximating to 1 plus f of x or 1 over f of x, it will be what? It will be e when this function approximating to 0, f of x approximating to 0. So it's like it, so the result will be e. If limited x plus a over x plus b or power x when x approximated to infinity e power c, we want to find the unknown c here. We can simplify this example by divided by x all terms here, right? Limited x approximated to infinity, x divided x equal 1 plus a over x, and here 1 plus b over x all power x, it will be e power c. Okay, understood? Okay, we can find the result here by distributing the power to numerator and denominator. Distributed the power here. Here will be power x and here will be power x. And distributed the limited to the numerator and numerator. Okay, so result here will be what? Will be thinking e power a. Constant here, it will be e power a over here limited. It will be e power constant here b. He tell us the result will be e power c, and we can simplify it e power e minus b equal e power c. Denominator equal the base here equals the base, then the power equals the power, then a minus b equals c. Then c will be a minus b. The result will be a subtract by b. If e power x equals summation from n equals 0 to infinity about x power n over factorial n. It's the rule, okay? You know this rule in your mind. We want to find limited here. I will cancel e power x and write summation from 0 to infinity. Okay? And here x power 3 in the numerator. Put here x n equals 0 here, x power 0 equal 1. 1 over factorial 0 equal 1, so the result will be 1. Okay, I will solve e power x. Understood? I solve e power x here. Put n equal 0, n equal 1, and so on to simplest the result. And write negative 1, negative x power 2 over 2 behind it. Okay, I will find the result here about e power x. The result will be 1, the first term. The second term, put n equal 2 here, it will be x power 2 plus x power 2, and factorial 2 here equal what? Put n equal 0 and 1, sorry, but again, put n equal 0, it will be 1 over 1, it will be 1, but x equal 1, x power 1 equal be 1 over factorial 1 equal 1, and then put x equal 2, it will be x power 2 factorial 2, it's meaning 2 times 1 equal 2, and then 8 3 x power 3 over factorial 3 equals 6, and then you can, and so on. Okay, this is the result about what? E power x. And then we can factorize or simplify it, cancel 1 by negative 1 and x by negative x, and x power 2 over 2 by x power 2 over 2. Then the result here will be x power 3 over 6 plus, put n equal 4, it will be x power 4 over factorial 4, it will be 24, and so on. It will be over x power 3 when limited x approximated to 0. Then we can write x power 3 height common factor between all term here. Then the result will be 1 over 6 plus x over 24 and so on over x power 3. We can cancel x power 3 here by x power 3 and then put x equals 0 here. It will be 0 and here 0 0 0. The result here will be 0 plus 1 over 6, so the result will be 1 over 6. About this example, the result will be 1 over 6. Okay, understood? Again, I cancel a power x and write the term is to infinity here and cancel 1, negative 1 and x power 2 over 2, so the result will be the remainder x power 3 over 6 and x power 4 divided 24 and so on. Okay, and then cancel x power 3 here by x power 3 to write a height common factor between two terms. The result will be 1 over 6 plus x over 24 and so on. Put x equals 0 and all the result here will be 0 plus 0 equals 0 plus 1 over 6. The result will be 1 over 6.